The derivative at a point, the formal definition. A derivative at a point indicates the instantaneous rate of change and the slope of the tangent line at a specific point on the curve of the function. So a specific point, so a specific x value. So the definition of this derivative f at the point x equals a is f prime of x is equal to the limit of f of a plus h minus f of a over h as h approaches 0. So as this h value and this h value approach 0, we have the derivative at the point x equals a. An alternative version of this definition also exists. Provided the limit exists, the derivative of the function f at the point x equals a is the limit f prime is the limit of f of x minus f of a over x minus a. So what is this really? So f of x can be looked upon as, in most cases, y, and x is simply x. And this other stuff helps us to become more precise as the x approaches a. But look at this, y over x. What does that tell us? That is the format for slope. And this part here allows us to become more precise and find the instantaneous slope at a certain point. But isn't that, it's fascinating because y over x is, change in y over change in x, rise over run, we get slope. So that just really solidifies the idea of how the derivative is the instantaneous rate of change and slope of the tangent line at a specific point. So here's an example. Find f prime of 2 for the function f of x is equal to 3x squared plus 4x minus 2. So f prime of 2 is equal to the limit as x approaches 2, 3x squared plus 4x minus 2 minus, so right now we have f of x, so then we're going to subtract f of a, because x approaches a, so that's a, so 3 times 2 squared plus 4 times 2 minus 2, all divided by x minus a, where a is 2. So, to continue, we simply multiply everything out. So that f prime of 2 is the limit as x approaches 2 of 3x squared plus 4x minus 20, because these all become, this is just the constant factor resulting in a minus 20 over x minus a, x minus 2. So how do we simplify this further? Well, we can see that 3x plus 4x minus 3x squared, 3x squared plus 4x minus 20 is equal to x minus 2 times 3x plus 10. Oftentimes, when you have something like this in the denominator, the upper function in the numerator will be able to be equal. We'll be able to factor one of those types, one of these kinds of factors out. So f prime of 2 is equal to the limit of x as x approaches 2 of x minus 2 times 3x plus 10, all divided by x minus 2. These bits cancel. F prime of 2 is equal to the limit as x approaches 2 of 3x plus 10. So f prime of 2 is equal to 3 times 2 plus 10. Therefore, f prime of 2 is equal to 16. So 16 is the instantaneous rate of change at x equals 2, and the slope of the tangent line at x equals 2 of the function f of x. So, instantaneous rate of change and slope of the tangent line are both the derivative at a certain point. So, let's graph the function and see if this slope value is reasonable. So we'll just do it for a visual confirmation. Say parabola that's slightly translated, so you can just use a graphing calculator or something. And it's a very steep slope. And so then at x equals 2, well, at least we can confirm it's very steep, so 16 is a reasonable number, and it's positive slope, positive 16, so at least in case we made a major mistake, we know we can disregard that notion because it's at least close, and we have visually confirmed it through the graph. Differentiate the following function at the given point. F of x equals 2x squared minus 13x plus 5 when x equals 3. Again, we'll use the same procedure. So f prime of 3 is equal as the limit x approaches a, which is 3, 2x squared minus 13x plus 5 minus, we'll plug in x equals 3 into the function. So 2 times 3 squared minus 13 times 3 plus 5, all divided by x minus 3. F prime of 3 is equal to the limit as x approaches 3. 2x squared minus 13x plus 21, because 18 minus 26, 39 plus 5. 5 minus this value results in 21. F prime of 3 is equal to limit as x approaches 3. Well, what can we do with this bit? Well, we know x minus 3 can factor out because it's a problem that has a solution, so we can almost always assume that that's the case. Canceling those out, 2x minus 7 is the result. F prime of 3 is the limit as x approaches 3. Plug in 3 for x. So f prime at 3 is equal to negative 1. That is our slope at x equals 3. So confirm this graphically just to get a general idea if we took the right steps. So 2x squared minus 13x plus 5. We get a function that is, we're looking at x equals 3. So plus 5, 2x squared minus 13x plus 5 looks something like this, let's say, yeah. So by x equals 3, the function is kind of starting to level out a little bit as it becomes ready to, again, move up like the parabolic function it is. So we know it's negative, and it's reasonably shallow slope as it approaches slope of 0. So our result is reasonable in a visual sense.